6. Y prime equals 4 over x minus 1 over x squared, and we are given y is 5 when x is 1. Good. Nothing new. Y. Which function I differentiate to get 4 over x? So please understand that this can be written like this. You should always look at this and think of that. So then 4 is outside. Which function I differentiate to get 1 over x? There is only one function whose derivative is 1 over x.
Natural log.
Yes, indeed, natural log of the absolute value of x. Now, we talked about this function a long time ago. So we said there is one function that we differentiate to get negative 1 over x squared. This is a very important formula. Which function we differentiate to get this?
The 1 over x.
Correct. Thank you. And of course, plus c, because there is always a 0 here. Silent, but it's there. Awesome. All I have to do now is find c. Y, when x is 1, y is 5. 5 equals. Well, it happens that natural log 1 is 0. So this is 0 plus 1 plus c. 1 over 1 is 1. Natural log 1 is 0. 4 times 0 is 0. 1 plus c. So subtract 1, c equals 4. I would have to rewrite the function with 4 in it. That's it. Nothing else. So then y equals 4, natural log of the absolute value, plus 1 over x, and plus 4. And this is it. Any questions on this?
Really quick, can you remind me why when you differentiate 1 over x, it equals to negative 1 over x squared?
Correct. So 1 over x is the same with x to negative 1. So when we differentiate x to negative 1, we bring down negative 1. We subtract 1 from the power times the inner function prime, which is 1. So then this is negative 1 over x squared. So
Gotcha.
the derivative of 1 over x is negative 1 over x squared.
Okay, thank you.
Thank you. Good. So let's continue. I would like to look, so all these are the same. This is exactly the same thing. Now, we have a method that I would like to show you called separating the variables. They're called separable differential equations. What is this? What does it mean? Okay. The easiest thing is to start with an example. So I'm going to start with 31, and then you choose the next one. dy over dt, no, not dt, is dx, sorry, equals 5x to the 4th y. Okay. So, see, there are basically two variables here. This is one, and this is the other. I don't want them to be present on both sides. I want to separate them. I want y to be alone on one side, and I want x to be alone on the other. My first step would be, in this case, to multiply both sides by dx. The left-hand side is dy. The right-hand side is 5x to the 4th y times dx. So 5 can be anywhere, it doesn't matter. X to the 4th is okay, dx is okay. Now, y is not okay. What do I mean by y is not okay? Y is still in the way. I have x alone on one side, but this y is in the way. I want this y somehow to end up on this side. I cannot remove it unless I divide both sides by y. When I divide this side by y, all I'm left with is 5x to the 4th dx. Awesome, that's good. When I divide this side by y, I have to write dy over y. So at this point, I separated, I was able to, this is not always possible. So there are other types of differential equations. In this class, we only look at the simple ones and the separable ones. So what do I mean by simple ones? Simple. Just find the antiderivative. And the second method is this. But there are other types of differential equations, more sophisticated, more difficult to calculate, to determine. But here we only have two, separable and the simple ones. Simple. Was I able to separate them? Yes. First, I multiply both sides by dx and I got this. And then I realized these are okay because they are on one side, but this piece should not be here. I can't remove it because it's multiplied, right? I cannot subtract or whatever. I have to divide because it's multiplied. It's a factor. So when I divide this side by y, I am left with 5x to the 4th dx. Awesome. I also have to divide the other side because it's an equation. And please notice, I do not continue to the sides, anything. Left-hand side equals symbol right-hand side. Left-hand side equals symbol right-hand side. Left-hand side equals symbol right-hand side. So I'm dividing both sides by y. Gone, but it has to be here, dy over y. Now, because they are separated, x alone with dx on this side, y alone with dy on this side, we are going to integrate. I integrate the left-hand side and I integrate the right-hand side. Let's start with the left-hand side because that's easy. 5. Which function prime is x to the 4th?
X to the 5th over 5.
Excellent. Plus a constant c. Great job. And of course, these two will go away 1, 1. Now, don't look on this side at all. Don't look. We're looking on this side. Which function prime is 1 over y? There is only one function that we differentiate to get 1 over y.
Natural log.
Yes, of the absolute value of y.
Okay.
So this is the step, the calculus step, in which we write natural log y equals x to the 5th plus a constant c. We haven't finished. Now we have to use algebra to finish it because we have to solve for y. We have to solve for y. But from this point on, there is no more calculus. It's just algebra. So let's redo the steps and then we'll finish up the algebra. So I was given an equation. dy over dx equals something. First, I multiply by the denominator. Both sides, of course. dy over dx times dx is just dy, and I have to multiply on the other side. Then I said I'm one step closer. However, this was in the way. So I had to divide both sides now by y. dy over y equals 5x to the 4th dx. Now, because they are separated, the variables are completely separated, x alone on one side, y alone on the other, and both of them have to have dx and dy, of course, correspondingly, then I can integrate. I started with the easy part, and then I thought of the left-hand side. And now you can say, why don't you put a c here? Well, This C with this C make up a one big C. So that's why there is no need to write plus C here and plus C here. We'll just put it on one side. So after simplification, I got this. From chapter 2, when we looked at log and exponentials, we remember the natural log has base E. We don't write it, but we know it's there. It's silent. Okay. So in order to solve this for y, we will have the absolute value of y equals e to this. E to x to the fifth plus a constant c. Now, the absolute value means plus or minus. One final step. If you remember, a to 4 plus 5 is the same with a to 4 times a to 5. So the same procedure, a base raised to a sum of two terms really means the base to x to the fifth times, careful, times e to c. We're going to replace this by another c. Let's call it C1 so it's no confusion. And this is the solution, and we just solved our first differential equation. This is it. So you understand that why I say that this is slightly more sophisticated. I have a lot of steps and I have to think. First I have to multiply, then I have to divide, then I have to integrate both sides, then I have to use algebra to find what I'm looking for. So that's what I'm saying. This section is a little bit more intense than the previous ones, in which we had a formula, we plug it in. Okay. So let's practice with anything else. Please choose. If you don't choose, then I will. Anyone would like to choose? So we're looking at problems 31 through 38. And then I would like 39 through 42. No one? Okay, I will choose 37. So dy over dx equals 7 over y squared. What do you think is the first step? It's okay if you're wrong. Just talk to me, please. What do you think will be the first step?
To get dy and y squared on the same side.
Yes. So we're going to cross multiply. Brilliant. Y squared dy equals 7 dx. That was even easier than the first one. Awesome. Now what? They are separated. What would be the next step once they are separated? What do I do now?
Integrate.
Excellent. That's it. Which function prime is y squared?
Y cubed over 3.
Excellent. Equals. Which function prime is 7? And now we're on this side, we're talking about x.
7x.
That's it, plus a constant c. That's it. Multiply both sides by 3. This is algebra now. 21x plus 3c. And how do I solve this for y? I don't want y cubed. What do I do to both sides to get y alone? What operator we apply to both sides to get y alone?
Cube it.
Thank you. You mean the cube root? Yes.
Yeah, sorry.
That's it. That's it. Exactly. That's it. And that's the final answer. We just finished solving the second differential equation. Good. Now let's look at one that also has an initial condition. So let's choose one from 39 through 42. With an initial condition now. Okay, I'll choose 39. You can choose the next one. Y prime equals 3x plus xy. And they're telling us that x is 0 when y is 5, or y is 5 when x is 0, same thing. Okay. Now this is a little bit tricky because I need to replace this by, what is the other notation for y prime? What is the other notation for y prime? They're trying to throw us off. That's why they put y prime instead of what?
Yeah.
Wow.
Yes, indeed. Now look here and see, what do you think of doing here first before we continue?
Get y by itself.
Yes, but I will factor out x because x is a common factor. So then, what do I have? I've
3 plus y.
Yes. Good. So I try that because I don't want the two terms with x, yada, yada. Okay. What is our next step now? That's the next step, meaning
Multiply by dx.
that's it. So I have dy equals x, y plus 3 in the correct order, times dx. What do I need to do now in order to separate them completely?
Divide by y plus 3.
Exactly. So dy over y plus 3 equals x dx. Y with dy on one side, x with dx on the other. I'm ready. For what? I'm ready to,
Integrate.
that's it. Let's start with the easy part. Which function prime is x?
Squared over x
Over 2.
over 2.
Yes, plus a constant c. Good. Now, here I have to be careful. Let's do this on the side. So the integral from dy over y plus 3, I have to use a substitution. I will say let t be y plus 3, and dt equals dy. So then the integral becomes dt over t. Then I'll replace it. Which function I differentiate to get 1 over t? I know we said that several times. I want to hear you say one more time. Which function prime is 1 over t?
Natural log.
Of t in absolute value. Good. Plus a constant, but we already put the constant. So now I have to replace this. So this is natural log of the absolute value of y plus 3. So this is what I have on this side. Natural log y plus 3. Now, we are given that condition. When x is 0, y is 5. This is given to us in order to find c. So let's see what we write. So y is 5. 5 plus 3, natural log 8. 0, c. So I have my answer. C is natural log 8. So finally, so we have natural log of the absolute value of y plus 3 equals x squared over 2 plus natural log 8. Now just algebra. Not a nice algebra. E to this power equals y plus 3. E to x squared over 2 plus natural log 8. So then y plus 3 equals plus or minus e to x squared over 2 times e to natural log 8. We talked about this property, so this property is simply giving us 8. So then y equals, move 3, negative 3 plus or minus 8 e to x squared over 2. Stop, because we have to make sure which one. Only the one that says when x is 0, y is 5. So this gives us two functions, negative 3 plus 8 times e, and the second one, negative 3 minus 8 times e to a power. But only the one we will accept, only the one that complies with the given initial condition. So let's try. When x is 0, this is 1. But the answer has to be 5. Negative 3 minus 8 is not 5. But negative 3 plus 8 is 5. So I will say only, only y equals negative 3 plus 8e to x squared over 2. This is the only one that is acceptable because we were given the initial condition. The other one gives negative 3 minus 8, which gives negative 11, which is not 5. So again, this encompasses a lot of material. That's why I'm saying that these are slightly more complex. Not difficult, but many steps, a lot of algebra, not that much calculus, right? But a lot of algebra, and then remembering that when I have an initial condition, I have to go back and make sure, because this gives us two functions, but only one is acceptable, because only one complies or fulfills the given condition.